So the next, we are going to look at groups of metals. Groups of metals. We classify metals into groups. We classify metals into what? Groups. According to the subshell they have. And according to the row they have in the periodic word table. You have the group 1 metals. You have the group 1 word metals. These group 1 metals are also called alkali metals. They are also called what? Alkali metals. They occupy the first row in the periodic word table. And they contain the S block. The group 1 metals are normally written as what? NS1. They contain the word S block. Example, lithium. Lithium has how many electrons? 3. So you can write it as what? 1s2, 2s1. They are the group 1 metals. And they are the what? S1 block metals. We also have the group 2 metals. They occupy the second row in the periodic word table. They are also known as what? Alkaline earth metals. And they are written in the electronic configuration as what? NS2. They are the S2 block. Example, you can have beryllium, you can have magnesium. If you have magnesium like 2412 magnesium, how many electrons does magnesium has? 12. It can be written as what? 1s2, 2s2, 2p6, and the what? 3s2. It belongs to what? S2 block. And because it contains 2 electrons in the what? S block, it is a group 2 metal. We also have the group 3 metals. In the group 3 in the periodic table, the first element there is not a metal, which is boron. But below boron, you have what? Aluminium, which is what? A metal. You also have gallium and so on. Down the group 3, they are what? Metals. Example, you use what? Aluminium. The group 3 metals also occupy the P1 block. You write it as what? NS2, MP1. Example, you have aluminium, which is 2713 what this. How many electrons does aluminium has? 20. So it can be written as 1s2, 2s2, 2p6, 3s2, 3p1. It is a group 3 metal. The only ones that has special name in metals are group 1 and the word group 2. The group 1 is called alkali metals. The group 2 is called alkaline earth metals. Okay. We also have the group 4. In the periodic table, topmost, you have carbon, which is a non-metal. You have silicon, which is between a metal and a non-metal, which is called metalloid. You have germanium, which is between a metal and a non-metal, also called metalloid. But after that, you have your tin, which is a metal, and your what? Lead, which is what? A metal. So we find out that down the group 4, the non-metallic character will decrease, while the metallic character will do what? Increase. The group 4 will changes from non-metals to metalloids to what? Metals. We have the group 4 metals, which are the tin and the what? Lead. The group 4 metals has 2 oxidation states, which are +2 and the what? +4. And the oxidation state of group 4 changes from stable +4 on top to stable +2 down. These are the group 4 metals. Okay. Now, as I rightly said before, between the group 2 and the group 3, we have the word transition element metal. They are called the D block metals. They are called the D block metals. They are called the D block metals because they occupy the D block. In the first row, we have about 10 elements that occupy the D block, starting from scandium. You have the scandium, you have the word titanium, you have the word vanadium, you have the word manganese, you have the chromium, you have the word manganese, you have the iron, you have cobalt, you have nickel, you have copper, you have what? Zinc. These are the transition elements group metals. And when you try to look at the electronic configuration, you'll find that scandium should be what? 21 electrons. And scandium will have the electronic configuration of what? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and the what? 3d1. Because it has an electron in the D block. It is a D block or transition element to metal. And when you come to be filling the D block, it has a special way of filling the D block. Like, if you can look at the way of filling the D block from scandium down, you have filling the D block, you have the 4s2 block, you have the word 3D. You have this, you have the 5 subshell. So when you start with scandium, you have the 4s2, you have the word 3d1. If you move into to talk about the titanium, you have the word 4s2, you have the word 3d2. You have the vanadium, you have the word 4s2, you have the word 3d3. All right? But when you come to chromium, which is supposed to be 4s2, 3d4, it does not happen like that. It will take an electron from the 4s2 to complete the D block, the half-filled D block. And the chromium will now become, instead of having 2 electrons from the what 4s this and having 1, 2, 3, and 4, it will now take 1 electron here and it will be here. It will now give you what? 4s1, 3d5. Then, if you finally talk about now manganese, if you finally talk about what? Manganese, it will now complete 4s2 and then 3d5. 3d what? 5. Remember that this one then, so the next one will now complete it. This is the half filled. Are you getting it? Then when you now go to the next one for the what? Pairing, where you have what? Ion. If you now have what? Ion. Ion will now have 4s2, 3d what? 6. Similarly, cobalt, we also have 4s2, 3d7. Nickel, we have 4s2, 3d what? 8. And a similar thing that happens with chromium will also happen with what? Copper. Instead of copper having 4s2, 3d9, instead of copper having 4s2, 3d what? 3d8, 3d8, it will also take 1 electron from the 4x and then now complete this, and that copper will now become 4s1, 3d10. Copper will become 4s1, 3d10, just like chromium is what? 4s1, 3d5, which is half filled. Are you getting it? Copper will also become 4s1, 3d what? 10. Then finally, zinc will now give us what? Zinc will now give us what? 4s2, 3d what? 10. These are considered to be the first transition element because they occupy the d block. And due to the inner filling, they have similar chemical properties. The transition elements also have colored salts. And sometimes, or most times, they are used as what? Catalysts.